Let's take a look at this lesson. Confidence intervals for population mean, standard deviation known. Now our assumptions are that sigma, aka the population standard deviation, is known. And you'll find in some textbooks they'll say if it's a large sample, then they'll use S as an estimate for sigma for a population standard deviation. But for this lesson, we're going to assume that population standard deviation is actually given. N is greater than 30, it's a large sample, or population follows a normal distribution. And sample is a simple random sample. Everything has an equal chance of being selected. Now our point estimate is a single value or point used to approximate a population parameter. Note the sample mean is the best point estimate of the population mean. Now our confidence interval is a range or an interval of values used to estimate the true value of a population parameter. And our margin of error is the difference between the observed sample mean and a true value of the population mean, aka the maximum error of the estimate. And let me start a new page here. This is try 2 on the video. First one, I realized I didn't have enough examples in the lesson, so I went and put some examples in. May not be the best examples, but we now have some examples. Okay, so let's say this is my confidence interval. Let's say 2 to 10. Okay, another way to write that is we put 2 comma 10 with parentheses around it. So either form is acceptable. Now the 2 is going to be our lower bound. So I'll label it as LB. The 10 is going to be our upper bound. Now our point estimate, which is X bar, when we're finding confidence interval for the mean, population mean, your point estimate, X bar, will be the value exactly in the middle. So to find that, we can take our lower bound plus our upper bound and divide by 2. So we take our 2 plus 10 divided by 2, which gives us 12 divided by 2, or gives us 6. So that's X bar, but that's also our point estimate. Well, the margin of error. The margin of error is the difference between your point estimate and one of the endpoints. So I could say the margin of error is your upper bound minus your point estimate minus X bar, or you could use this formula if you wanted. X bar minus your lower bound. Well, let me show this one right here. Upper bound minus X bar. We said upper bound was 10 minus X bar, which is 6. So our margin of error is 4. So this shows you how the different pieces tie together. A point estimate, our margin of error, and then lower bound and upper bound. Now how you interpret a confidence interval, let's say we got this interval here. It goes from 98.08 to 98.32. And we did this with 95% confidence. So how we interpret that is we are 95% confident the true value of the population mean falls somewhere in that range. We don't know where it falls, but we're 95% confident the true value of the population mean falls between 98.08 and 98.32. Now this is how we're going to do confidence intervals on the calculator, and at the very end of this lesson I'll do it by hand to show that. So we'll find confidence interval by, and that's his T83, but it's T84 also. Press our stat button, choose test, choose the interval, highlight stats or data if you're given raw data, enter a standard deviation, mean, N, and C level, highlight calculate, and then press enter. And then find your margin of error is you subtract the smallest part of the interval from the mean. And we already talked about that, how to find E. Let's take a look at an example. And I just made these examples up, so hopefully they're not horrible. Okay. And if I can get back there, there we go. Ages of students at college follow a normal distribution. If a sample of 45, so N is 45, has an average age of 20.1, so X bar would be 20.1. Now it doesn't say sample mean, it says average age. How do I know it's X bar? It's referring to the sample. If it's referring to the sample, it has to be X bar with a population standard deviation of 1.2. So they're telling us that sigma is equal to 1.2. Construct a 95% confidence interval. So we want 95% confidence interval. So let's go to our calculator. Okay, so press my stat button, right arrow twice over to test, or you can do a left arrow to go there quickly. We want to choose a Z interval. So I go down to number 7, and I'm going to press enter on it. Or you can press the 7, and it'll do the down arrow and enter for you. Now, data is when you're given raw data. We're not given raw data, we're given summary statistics. So we're going to right arrow over, put our flashing cursor on stats, and press enter one time. Then down arrow, put in 1.2 for sigma. X bar we said was 20.1. N is 45. Now C level is our confidence interval we want to find. And we said 95%, so we put in 0.95. Mine was already 0.95, but and then press enter, and then press enter and calculate. And this right here is our confidence interval. So 19.749, comma, 20.451. That would be our answer. Okay, I got another example here with raw data. Sample scores are listed below. Assume the scores are normally disputed. I put that on there because I didn't want to type in a bunch of numbers into the calculator. And it says construct a 99% confidence interval for the population mean given the population standard deviation is 8.5. So they're telling us the population standard deviation is, what was it, 8.5? Yeah, 8.5. And we want a 99% confidence interval. Well, when you're given raw data like this, excuse me, you first want to input that into your calculator. So I'm going to go into my stat, and I'll go into my edit. So do enter on edit. And I got some data here, so I'll delete to clean those out. There's faster ways of doing that, but that's the safest way. Now we'll enter our data. So we got 80, 82, 82, 84, 90, 95, 97, 97, 100. Now I have seen some books refer to that you can't have like a bimodal, multimodal. But again, I'm just working with these data points. Realize that every book you look at may have a little bit different variation of that. Okay, so I'm going to exit out after I get those input in. I double checked myself to make sure I typed my numbers in correct. Hopefully I double checked correctly. So do second mode. And now we want to go do Z interval again. So press stat, go over to test, and choose Z interval. This time I'm going to do a 7 to choose it very quickly. We're given raw data, so I want the data. So I left arrow over, put my flashing cursor on data, and press enter one time. Now it changes, and it wants us to enter in sigma, population standard deviation, which we said was 8.5. So I'll down arrow, put in 8.5, enter. Now list should be set to L1, so defaults that. If yours doesn't say L1, you can do second 1 to put L1 there. Frequency should stay as 1. If you don't have a 1 here, you need to shut off alpha and then press your 1. And then C level, we'll put in 0.99 because we want 99% confidence interval. Press enter, and then we'll press enter again. And we're given 82.368. And we're given, if I can get back to my calculator, 96.965. Now they also give us X bar. Remember, X bar is your point estimate. So if you got any problem that asks you to find the point estimate, first find your confidence interval and then it'll be given to you. Now, how you interpret this, the question wasn't asking us how to interpret it, but we say we're 99% confident true value of the population mean falls somewhere in this range. So that'd be our answer. Okay. Now here's the formula for sample size. Sample size is your z alpha divided by 2, the critical value, times sigma, all divided by e. Sigma is your population standard deviation, of course. E is your margin of error, your desired margin of error, and then you raise all that to the second power. So let's look at a problem dealing with that. 3. We got ages of students at college follow a normal distribution. If the population standard deviation is 1.5, so they're telling us sigma is 1.5. And we want to estimate the mean within 2 years. Now, within always indicates your margin of error. So E is going to be 2. Now, I'm making these numbers up, so hopefully it doesn't give us some real bizarre results, but we'll see. What should the sample size be, assuming we want 95% confidence? So we want 95% confidence. Well, from our formula, we need sigma, which we're given. We need E, which we were given. We also need this critical z-score. So let's see how to find that. And I'll do the picture up here. For sample size, you always set up your picture like this. Whatever confidence they want, whatever they give you, 95%, 99%, then you can put that in the middle here. So we'll put 0.95 here. Now all of this adds up to 100%. So if 95% is in the middle, then 5% is split up into tails. So this will be 0.025, and this will be 0.025. Now our critical z-score, that's not 2 divided by 2, that's alpha divided by 2, is right here. And how we find that is using INV norm. Now INV norm is always based upon the area to the left. So I'm looking to the area to the left, and I have to add up all of this. So I'm going to add up these two values. 0.025 plus 0.95 gives us 0.975. And let's plug that in our calculator. So we'll do second vars, choose INV norm. I'll do 3 to choose it. 0.975. Press enter. How many decimal places? I have no clue. I would try 2 or 3. If your book's answers are based upon tables, then it'll go 2, sometimes 3. If you put all the decimal places, your answer will be more accurate than the books. So that's kind of your call. But if you want it to match the book somewhat, then take it to 2 or 3 decimal places. Trying to get back to my formula. Here's our formula. So we got N is equal to Z alpha divided by 2 times sigma over E squared. So let's plug in everything we're given. Z alpha divided by 2 we said was 1.96. Sigma was 1.5 over E, which we said was 2, and then squared. And let's see how bizarre my, when I make the numbers up, sometimes it comes out pretty weird. So to beginning parentheses, 1.96 times 1.5 divided by 2, close parentheses, and then squared. 2.16. Need to talk to 2 people. 2.1609. Well, whenever we get any kind of decimals, we always round up. So we go to 3. And that's to make sure that we have enough individuals. Now, what I've done here, though, is I made up the numbers. When you make up the numbers and you get bizarre results, probably because my E is so large in comparison to my population standard deviation, which is why that comes up like it did. But anyway, you see the basic steps anyway. Okay. Now here's another example of finding the critical z-score. We have 96% we're trying to find. We put 96% in the middle, and then we split 4% into the tails. So put 2% here and 2% here. Now if we got 90, if we look at this z-score right here, I say it's 98%. Why is it 98%? Because I'm adding the 2% plus the 96%, the area to the left. And notice I put it in decimal form, so it'd be 0.98. So then doing on a calculator, you see I say INV norm and 0.98 comma 0 comma 1. You don't have to put the 0 and 1. It defaults that by if you leave it off. Anyway, that gives you another example. Now our range rule of thumb, this is if sigma isn't given, then you could use high value minus low value divided by 4. And when finding sample size, always round up if any decimals. This is probably not a good estimate to use for sigma. If you're going to use anything, if you don't get any value, any idea what sigma is going to be, then use a large sample. Use its sample standard deviation, and that'll give you an estimate. Not the perfect world, but if you have no clue what sigma is, then you can do that. Okay, now these are the formulas on how to do it by hand. So we got our lower bound and upper bound. So we got x bar minus z alpha divided by 2 times sigma divided by square root of n. And upper bound is x bar plus z alpha divided by 2 times sigma divided by square root of n. And your standard error is the sigma divided by square root of n. So if you got any problem asking you to find the standard error, you plug in sigma, plug in n in this formula, and you'll get it. Well, I'm going to look at an example here. And I think this is, I don't think I changed this from the earlier example, but we'll see. Let me start a new page. Okay. It says, so I'm going to get my pen to work here. Ages of the students at college follow normal distribution. If a sample of 45, so n is 45, has an average age of 20.1, so that's x bar. With the population standard deviation of 1.2, construct a 95% confidence interval. And I'm going to use these formulas somewhat. I'm going to use a little bit of the calculator. For lower bound, we're going to have x bar minus z alpha divided by 2 times sigma divided by square root of n. In our upper bound, we got our x bar plus z alpha divided by 2 times sigma divided by square root of n. Well, we're given some of these. X bar we know, that's 20.1. Minus z we don't know. So let's find that. Now you can use the tables like we did when we covered normal distributions and look it up, and that's fine. I'm going to use a calculator for that part. So 95%, we'll put 95% in the middle here. And that means we split 5% into our tails. So I'll put 0.025 here, and I'll put 0.025 here. Now this right here is our z alpha divided by 2, which we're going to find using INV norm. Now INV norm, you put in all the area to the left. So we add 0.025 plus 0.95 gives us 0.975. See what that gives us. Second vars, choose INV norm, 0.975. and we get 1.96. I'll take it 2 decimal places. So z alpha divided by 2 is 1.96, and times sigma, which we said was 1.2, divided by square root of n, so square root of 45, equals something. And this one will be 20.1 plus 1.96 times 1.2, or sigma, divided by square root of n, which is square root of 45. And that's going to give us something. So let's plug that in and see what we get. 20.1 minus 1.96 times 1.2 divided by square root of 45. Enter. And we get 19.749. Now we want to do the other one, which is exactly the same except there's a plus there. So if I do second enter, that'll bring up the previous entry. And I can up arrow and then right arrow over and put a plus there and then press enter. And that gives us 20.451. Assuming I typed it in correctly. So our confidence interval would be 19.749, comma, 20.451. Now I think I did that over here, assuming I didn't change numbers. 19.749, yep. 20.451, yeah. The only thing I didn't do by hand is look the z-score up in a table, and not too tricky. Remember the z-score, you have to you're still working with the area to the left, the 0.975, and you're looking for the value in the middle of the table that's closest to 0.975. And then you go to the left and you go up, and that gives you your z-score. So it's pretty basic. If I had a table handy, then I'd show it to you. I'd probably Google one. Let's see. Assuming it doesn't take forever. There we go. Go to Google. And let's see, standard normal table. Okay. I guess it doesn't matter which one to choose. Though it would be nice to have one I can read. Let's look at this one. And view page. Okay, that may be. I have no clue what that is. Fisher's table. That's not what I Googled. Standard normal. Well, math captain. That's got to be good, huh? I'll give up here in a minute. Okay, this one will work. Okay, what we're looking for is the area left, which is 0.975, the same value we entered in INV norm. So I'll look in here for 0.975, and here's 0.975. So if I come straight over to the left, that's 1.9. And if I come straight up, that gives me my 0.06. So that gives me my 1.96. So again, not hard if you got a table handy. I think that was the last of that. Yes, that was the last slide.